Hello, and welcome to another edition of Todd Talks, where we take teaching theory and turn it into teaching practice. In continuing our series on the depth and complexity icons, what we're going to be talking about today are patterns. And so the question becomes, what are patterns? And so there are different levels of patterns, which is what makes it more complex and more in depth. So for example, you might have patterns that look like this, where we have shapes. So we have a circle, a square, a triangle, and another circle. So using logic, the most simple pattern here is what comes next is going to be the square. Because if we're going circle, square, triangle, circle, and then square would be next. So that would be our answer, would be a square. However, it might look a little bit different. So for example, if the pattern were circle, square, triangle, circle, and then it repeats itself, and you have, again, circle, square, triangle, circle, then what comes next, if that's the pattern, would be a circle. And so you do have to dig a little deeper. You can't assume the simplest. You can probably guess that that is probably the answer. But at the same time, there are, patterns can get a little more complex than the simple patterns. Here's another one, pretty simple one. So if we're looking at these arrows, then what would be our next pattern? It would be the up arrow. We can look at patterns in ELA. So if we look at a pattern like this, where we have rain, train, main, and then another, if you're repeating, it wouldn't be mind, it wouldn't be, like stem, it would be brain, because that is what you're having a rhyming pattern here. Similarly, we have this mice, twice, nice, and then you have this, which would be dice. So we have a rhyming pattern going on. But again, you can get a lot deeper in the patterns. So if you look at a book and you notice that a character repeats certain patterns. So Voldemort in the Harry Potter books follows the same patterns. He's always trying to do something to Harry. He's trying to, finish the job that he started when he tried to kill Harry, and he's continuing that. So that's his pattern, and he doesn't deviate from that pattern. And you can guess that that pattern is going to come up someplace in the book. And so you can have more subtle patterns such as that. You can look at patterns in math, such as this, especially with sequence. So we have 3, 6, 9, 12, 15. So if you're looking for a pattern here, what is your next number going to be? And that would be 18. The reason being that these are all adding 3. 3 plus 3 is 6, 6 plus 3 is 9, so on and so forth, till you get 15 plus 3 is 18. That's a pretty simple one. You have one, it could be like this, which is a little more. So you're adding 3 each time. That's what you were doing before. For this one, 1, 2, 4, 8. Then you have to try to figure out, okay, they're not even and odd patterns. So it's not 2, 4, 6, 8 or 1, 3, 5, 7. So you have to figure out what is going on here. And so if you do 1 plus 1, you get 2. 2 plus 2 equals 4. 4 plus 4 equals 8. And then so the answer would be 16. Because what you were doing is you're doubling the number each time. There are patterns in science. So for example, if you look at the years that cicadas show up, you look at these numbers and you look at the years that this happens, and you can try to guess, you don't even have to guess, you can tell when the next group of cicadas is going to come. Because if you do the math, there are 17 years between each of these years. And so the next time the cicadas are going to come is going to be in 2038. Because that would be 17 years. You look at patterns in science, and sometimes patterns are obvious, and sometimes, and some we can try to predict. It doesn't mean that it's going to happen, but we can look for patterns to try to guess. So for example, the weather is very unpredictable, but there are patterns that weathermen and meteorologists look at in order to determine things. So if you're looking up at the sky and it's really sunny, And then you look a little bit later and it's starting to cloud up a little bit. And then all of a sudden you see these dark clouds and they're covering the sun. You can predict what's going to happen next, most likely. More than likely, it is going to rain. Now, is it a guarantee it's going to rain? No, because weather is unpredictable. But by looking at patterns, you can try your best to guess what that would be. You can look at patterns in social studies. So look at this map of the United States. The red represents population, so where people live. So this represents people. And so you can look at this map and look for patterns on where people live. And so you can make some really obvious conclusions here, which is that most people live in the eastern part of the United States. But looking at that pattern, the logical question becomes why? Why do most people live on the East Coast? And there's a couple answers there when you really look at things. So first off, it's the history of the United States, which is that people came from Europe, settled here, and started to work their way west. Another reason why is because so you have the Rocky Mountains that are right in here, which makes a lot of the land inhabitable or very difficult to live on. So you have a lot of these up here, such as Wyoming, which are very flat and aren't very livable. They're beautiful, but they're not very livable. And so as a result, you have these heavy populations here, like in New England, where you can't even discern where there's a white spot. And these are really packed in. And then when you move out west, it spreads out a little bit. Except when you get to California, you see these dents in Oregon and Washington, because these are really beautiful areas with great weather and livable. Florida is interesting. When you look at Florida, you see that almost all of Florida is inhabited except for this area right here. And you're like, well, why isn't it? Because the further south you get, the warmer it gets. It'd be nicer. But then you have to look at the geography, that this is swamp. And so it's not very livable. Now, in another 20, 30 years, they'll probably fill in those swamps and there will be houses there. Because Florida originally wasn't this populated. But as they keep filling in swamps and keep building houses, they're going to continue to grow in Florida. So you can look at patterns such as that. You can look at patterns in technology such as this. So if we look at this right here and we see we have a phone with a receiver and a dialer, finger dial, and then we have this where it has the punch key, and then you have, and so what you're seeing is an evolution of how you dial the number. Here you had to use the rotary. Then as it started to progress, you could push the buttons. And then as it progressed, you could push the buttons on your actual cell phone you could carry in your pocket. And then finally, you have this phone, which has no buttons on it at all, except for on the screen. And so the patterns you notice is that each time you see an iteration of this phone, it's improving. It's getting better. Here are some patterns that may be brain teasers. So if you look at something like this, you have this, 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 and then so logically, which one of these would go here? And your answer, of course, would be C. Because if you look, this is opposite of this. This is opposite. So in other words, it is changing to an opposite color. So if this is purple and this is yellow, this is purple, so on and so forth. So if this is yellow in the upper left-hand corner, then logically, if it is following this pattern, it's got to be a purple one. And the only one of these which has purple in the left-hand corner is C. And so C would be your answer that would go there. That would be the logical pattern. Now, if this pattern had been something different, one of these other ones might have applied, but this is the pattern that's been established, and so you have to guess what this is using logic. You have mathematical brain teasers like this. So you have these three numbers, and then you get this center number. And so you have to try to determine, how did you get this center number? So you can go 6 plus 2 is 8, and 2 plus 2 is 10, but that doesn't give your answer. Could you go 6 plus 2 is 8, or 6 times 2 is 8? But again, it doesn't make sense. So, and you have to look at all three of them and see whether they all follow the same pattern. So if you're looking and putting these three numbers together, what is the number here in the corner? So the answer for this one is 3. And the reason why it's the answer 3, I'm going to walk you through this. So it's the top number minus the bottom left-hand number multiplied by the bottom right-hand number. So let's put this to the test here. So this top number, 6 minus 2 is 4. 4 times 2 is 8. So let's test the pattern to make sure it works. So 7 minus 5 is 2. 2 times 3 is 6. So we're starting to see the pattern here. So 7 minus 4 is 3. 3 times 2 is 6. And then here, 6 minus 5 is 1. 1 times 3 is 3. So the answer would be 3 there. And so, but you have to look a little bit deeper for that to see that pattern. If you just took the first thing that came in the mind, it might not match up with this one right here. And so patterns are trying to recognize and predict based upon repetition, things that are repeating, things that are occurring the same way. Now, it's not always as clear cut as some of the patterns that you've seen here. When we look at patterns in our own lives, we might see like a pattern of behavior. So if a kid always is doing the wrong thing, and then you catch them doing something, and it turns out they could be doing the right thing that time. There's no law that says they have to continue those patterns. Now, more than likely, they're probably repeating the patterns, but regardless, it doesn't have to repeat. We talked about the weather as being one as well, but there are lots of patterns in there. So what are the big questions when it comes to patterns? Well, here's some of the questions you might ask. One might be, what is the order of events? So if you're looking at something, there's a logical order. So for example, when you wake up in the morning, you usually brush your teeth or use the restroom. You may take a shower, then you might get ready for school, and then you go to school. But that's the pattern. But does that pattern change on Saturday? Probably. Maybe you sleep in. Or you might be someone that takes a shower in the evening rather than the morning. So that pattern might be, or you might decide one time to take it in the evening rather than the morning. So the pattern is common, but it's not written in stone. It's not something that has to happen. So you have to look for, but you do look at order events you can use that to predict a pattern. What elements, events, or ideas are recurring? So in other words, they're repeating. They're happening over and over and over. So if you look at a football team and it's winning all of its games, when it comes to the next game, you could probably, and they're playing someone who hasn't won a lot of their games, you can probably predict that the team with the better record is going to win because they have shown a pattern of that. They have shown that recurring. Now, doesn't mean the other team can't beat them. Absolutely could happen. But a lot of times, a team that has a better record than another team is going to be the one that wins. There are always exceptions to that, but for the majority of the time, that's what's going to happen. It could be, what predictions can you make based on the pattern seen? Again, you're going to take these patterns and try to predict what's going to happen. It doesn't mean it's going to happen. But if you can get good at predicting, then you can start to avoid things. So in other words, one of my favorite sayings is that if we learn from the past, we won't repeat it in the future. So for example, if we look at patterns in the past of things that we've done and how things have gone wrong, and we try to avoid doing that same thing, then we might be able to change history or cause history not to be. So for example, there are a lot of civilizations such as the Roman Empire and the Greeks and the Mesopotamians that got too big and the government crumbled, and because the people got angry, and as a result, those civilizations came to an end. So in our current world, can we avoid that? Can we prevent that from happening with our own government and our own people to try to make sure it doesn't happen that way? And so if we don't heed the lessons of history, then it's bound to repeat itself. Now, again, not an exact science, but you can make a lot of predictions there. And so when we're looking at patterns, some of those patterns are going to be really obvious, but some of them you have to look a little bit deeper. You have to dig a little bit deeper and use those patterns to try to predict what might happen. One way that you can practice patterns is by doing logic puzzles such as sudoku. Sudoku is a number logic puzzle that uses patterns to figure out where certain numbers go. And these patterns are very consistent. And if you follow the patterns, you can find out what numbers go where. So just very briefly, the way Sudoku works is you have 9 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which are signified by these darker lines. In each of these boxes, you have to place the numbers 1 through 9. So for example, this big box already has a 5 in it, so none of these can be a 5. In addition, you cannot have the same number in rows. So this 5 cannot be in any of this row, any of these boxes in this row, nor can it be in any of the boxes in the column underneath it as well. So 5s can't be there either. And so what you start to do is you start to look for patterns. So one pattern you can look for are repeated numbers. So we have a 6 here and a 6 here, but no 6 in either of these two boxes, or any of these boxes. Because this row is taken and this row is taken, that means the 6 has to go in this box or this box. So we check our columns. There are no 6s. So we don't know for certain that which one the 6 goes in, but we know it's going to go in one of those two. So I put a small number to indicate that that's where it could go. But I'm not going to guess. I'm going to use additional patterns to try to figure that out later. This is why Sudoku is so good, is that it has multiple patterns to it and multiple layers when you're solving this. And so it gets into really complex patterns. Now, some of these patterns, you can figure out the absolute number. So for example, if we go down here to where we have this 8 and this 8. So we have an 8 is nowhere in this box, but it is here and it is here. So it can't be in this column. It can't be in this column. It has to be in this column right here. And if you look at the rows, you've got an 8 in this row. So that means an 8 has to go here. And now we have an 8, an 8, and an 8. So now that pattern of 8s in that particular, those 3 boxes is complete. And then as you start to continue to figure out more, the more numbers that you start to place, the easier it is to figure out the rest of the puzzle. Another pattern that you can look for in Sudoku is the lack of numbers in boxes. So let's take this big box right here. We have a 1, 7, 9, and a 5. And we know that the 6 can go in either of these two boxes. There's a couple numbers few numbers that we don't have. We don't have a 2, we don't have a 3 or a 4 or an 8. And so what we can do is look at the other numbers surrounding it and the patterns that they create to help us inform what number goes where. So for example, the 2 cannot go in this particular column because there's a 2 down here. There are no 2s in the rows. So that means a 2 can go here or here, here, or here. When you look at 3s, you have a 3 in this column and a 3 in this row. Nothing in these columns or these rows, so a 3 could go here, or it could go here. When you look at 4s, we look at this 4, we look for so in this column, there's no 4s here. There are no 4s in the row, so that means a 4 could go here, here, or here. And so now we're starting to eliminate things. And so when we start to get definitive answers, it will help us. So for example, when we start to look at, we already have the 6. When we get to the 8, we have an 8 in this column, an 8 in this column. So the 8 could go here or here, but there's an 8 in this row. So the 8 has to go here. So I can put a big 8 and eliminate these other boxes because that's the only place that the 8 could go. We already have a 9. So then we look at these patterns that are left and we could try to guess, but instead we'll try to solve some of the other boxes, which will help us determine which number goes in the right place. And this is how you use the patterns to determine which numbers go where. If you would like a more extensive explanation of how Sudoku works, you can follow this link right here to another Todd Talk that discusses Sudoku puzzles. And if you want examples or reproducibles of Sudoku puzzles, you can follow this link listed right here, and it will give you some blank ones that you can begin to work on. But using the Sudoku and these patterns helps you to start to recognize patterns in other things in life where it may not be as definitive as a Sudoku puzzle, but you're looking at patterns and seeing how those patterns work to predict something that could happen.